Every January, a silent force reaches its peak. It does not shake the ground, it does not darken the sky, and it does not sound like anything we can hear. But it is powerful enough to pull the surface of our planet. Each year, at the beginning of January, Earth experiences one of the strongest tidal events of the entire year. The moment when the sun, the moon, and the shape of Earth's orbit combine to create the maximum gravitational influence on our oceans. We rarely notice it, but the sea responds. And the ocean's surface rises higher than usual, following an invisible command written by the mechanics of the cosmos. Earth does not move through the solar system with constant gravitational conditions. The pull we experience from the sun changes depending on where we are in our orbit. At the start of January, Earth passes through perihelion, the point where it is closest to the sun. That small change in distance increases the gravitational force we feel from the sun by around 3 to 4%. On its own, that might seem insignificant. But when combined with the gravitational pull of the moon and the timing of its orbital cycles, it becomes the foundation of a yearly gravitational episode that shapes the world's tides. Just like Earth's distance from the sun varies, the moon's orbit is not perfectly circular. Sometimes the moon is farther away, and sometimes it is closer, a point known as perigee. When the moon is at perigee, its gravitational pull on Earth is noticeably stronger, because tides are created primarily by the moon. Any increase in the moon's gravitational pull translates directly into higher tides. These are measurable, predictable, and globally observed increases in sea level that scientists track throughout the year. But when perigee occurs close to the start of January, its effect becomes amplified by another cosmic factor. This amplification comes from a phenomenon known as gravity stacking. When multiple gravitational influences line up, their combined effect becomes stronger than any one of them alone. In January, this happens when three things occur within the same period. Earth reaches perihelion, the moon reaches perigee, and the Earth, moon, and sun align during a new moon or full moon. When these events happen together, the pull on Earth's oceans is at its maximum. Coastlines around the world experience what are known as king tides, especially high tides that rise significantly above the normal tidal range. These are not storms, not anomalies, and not warnings. They are simply the physics of celestial bodies lining up. When a king tide occurs, the ocean surface can rise 20, 30, or even 60 centimeters higher than usual, depending on geographic location. Cities built close to sea level feel the impact most sharply. Harbors see water pushing farther inland. Sea walls reach their limits. And tidal marshes, estuaries, and river mouths experience surges that reshape their daily patterns. None of this is catastrophic, but all of it is real. The ocean is responding to a shift in force that begins nearly 150 million kilometers away. And it does so every year with predictable regularity. Interestingly, tides do more than move water. They also move mass. And whenever mass shifts on Earth, however slightly, it changes the planet's rotation. When tidal forces pull the oceans outward, Earth responds by slowing down, not in a dramatic or dangerous way, but by a few measured milliseconds. These slowdowns are tracked precisely by international timing organizations. Even tiny fluctuations must be accounted for in global timekeeping systems. The length of a day is not perfectly fixed. It stretches and contracts depending on how the oceans move. And January is one of the times when that shift is most pronounced. The extra energy delivered by January's tidal forces also influences ocean circulation. Stronger tides can slightly alter the movement of coastal currents, change the mixing of warm and cold water layers, and create a brief seasonal pulse of tidal energy. While subtle, these changes ripple through marine ecosystems, shaping the distribution of nutrients and the behavior of sea life. Even structures built along the coast, from piers to breakwaters, feel additional pressure during these seasonal peaks. A reminder that the boundary between land and sea is never fully stable. Predicting these tidal events requires a combination of astronomy, oceanography, and precise measurement tools. Scientists use satellite altimeters to measure the height of the ocean surface from space. Tide gauges along coastlines record the exact timing and magnitude of each tidal cycle. Gravitational models determine the alignment of the sun, moon, and Earth down to fractions of a degree. With this combined data, king tides in January can be forecasted years in advance. Their timing is not a mystery. It is a repeating pattern built into the structure of Earth as orbit and the moon's path. If the events that shape January's tides were to intensify, if Earth's orbital eccentricity increased, or if the Moon's perigee lined up even more closely with perihelion, the resulting tides would be higher and more dramatic. Conversely, as the Moon continues to drift away from Earth at a rate of about 3.8 centimeters per year, tidal forces will slowly weaken over millions of years. The gravitational choreography that shapes our oceans is not permanent. It evolves with time. And every shift in orbit or distance changes how the sea behaves. And yet, despite the complexity of the forces involved, the experience itself remains quiet. No indicator in the sky announces the arrival of January's maximum tides. The coastlines shift, the oceans rise, and then they recede. A silent mark of Earth's annual passage around the sun. Each year, the interplay of gravity reaches its peak, gently pulling at the edges of our world. And though we rarely notice, the oceans feel everything, responding to a rhythm that has echoed across the planet for billions of years.